In today's lecture, we've looked at things like temperature, pressure, volume, the ideal gas laws, and how you go about measuring temperature, what temperature means and what temperature scales are. We started off by looking at the zeroth law of thermodynamics and what thermal equilibrium means. Thermal equilibrium implies a situation where when two bodies are in contact, no heat flows between them. We can then use the zeroth law of thermodynamics to tell us that if body A is in thermal equilibrium with body B, and body B is in thermal equilibrium with body C, then body A must also be in thermal equilibrium with body B. This then begins to tell us what temperature means. Temperature is a measure of the thermal energy contained within a body. We can then use this to help us define temperature scales. And when we have a temperature scale, it's important that it must have fixed points. Okay, so for example, fixed points might include the freezing point of water, the boiling point of water. They may be the temperature when all atomic motion ceases, and they may be the triple point of water, where solid, liquid and gas can exist at the same time. Once we've defined these points, we can put an arbitrary number of intervals in between. So for example, in the centigrade scale, we have the freezing point and the boiling point of water, and we define 100 steps between them. In the Kelvin scale, we have the triple point of water and the temperature at which all atomic motion ceases. Okay, that's 0 Kelvin. The triple point is 273.16 Kelvin. And also, we say that the step size is the same as in the centigrade or Celsius system. In order to measure the temperature then, we must have a physical property that changes with temperature. And this could be, for instance, something like volume, it could be pressure, it could be electrical conductivity, it could be resistance, it could be voltage. There's a whole load of things. And the standard way, the standard thermometer, is a constant volume gas thermometer, where we measure the change in the pressure of a gas as the temperature changes. Now we know from the ideal gas laws that the pressure is directly proportional to the temperature at constant volume. Similarly, we know from Boyle's law that pressure and volume are directly proportional to one another, okay, as long as we keep the temperature constant. And similarly, there's another relationship between volume and temperature at constant pressure. Okay, so we can use this then to measure the temperature, which is what happens in the constant volume gas thermometer. We saw in the demonstration that as we heated the constant volume up, the pressure increased. As we cooled it down, the pressure decreased. So now we can use this to set up our system of measuring temperature. We've also seen that we can combine the ideal gas laws together. So for instance, we know that PV over T is a constant for a fixed volume for the same gas. We can expand this by using the Avogadro hypothesis. And the Avogadro hypothesis stated that equal volumes of gases at the same temperature contain the same number of molecules. Okay, and the key point here is this is independent of the kind of gas we have. So for instance, 1 mole of oxygen at the same temperature occupies exactly the same volume as 1 mole of nitrogen, occupies exactly the same volume as 1 mole as methane. Now at standard temperature and pressure, which is 0 degrees centigrade and 1.01 times 10 to the 5 pascals, we know that this volume is 22.4 litres. This then enables us to come up with the ideal gas equation. Okay, and the ideal gas equation tells us that PVM, where Vm is the molar volume, equals a constant called R multiplied by the temperature. So R is the ideal gas constant, and if you put in the numbers, okay, so for instance at standard temperature and pressure, we know that the volume is 22.4 litres, we know the pressure is 1.01 times 10 to the 5 pascals, and we know that the temperature is 0 degrees centigrade or 273 Kelvin. Remember, you must always use Kelvin in these calculations. Okay, we can work out a value for the ideal gas constant, which is 8.3 joules per Kelvin per mole. We've finished the lecture at this point, and if you remember, I left you with some exercises, and we'll go through the answers to the exercises at the start of the next lecture. Thank you very much.